Now that we have learned how to write complex numbers in trig form, we can now do some of the same operations on them as we did when they were in algebraic form. So let's start out by multiplying complex numbers, what they call the product theorem. Okay, the idea is when you multiply two complex numbers in trig form, you're going to multiply their absolute values, which would be their R values, the distance that the complex number is from the origin, and you're going to add the arguments. The arguments are their angles. Okay, and it's that basic. So, for example, find the product. Here are two complex numbers. Both are in trig form. Okay, so I'm going to multiply their R values, their R's or their absolute values. So I get 7 times 2, all right, which is 14. So what that means is that the absolute value that is the result of multiplying these has a distance of 14 units from the origin. Okay. Then I'm going to add their angles, and I'm going to go ahead and use compact form. I guess it'll be a lot of writing. So I'm going to add the angles. So in my first complex number, the angle is 45. We can see it's the same. My second, it is 315. So I'm just going to add those, 45 plus 315. And that will give you the trig form of the product of those two complex numbers. So it's going to be CIS, and my new argument or my new angle is going to be 315 plus 45, which is 360. Okay, now this is fine, totally acceptable. In my math lab, I will make a comment that typically they'll ask you for this angle to be in the interval from 0 to 360. And notice that the 360, there is no equal to on it. Okay, because 0 degrees and 360 degrees are coterminal. So this is fine with me. You might see it also written as 14 CIS 0, which to me seems weird, but anyway, heads up. Now, if you wanted to, just for fun, you could write this in rectangular form. So that means you would take 14 times the cosine of 0, which is 1, plus the sine of 0, which is 0, and I can see that I end up with 14, a real number. Okay. If you wanted to, you could go back and convert the two originals to rectangular form, multiply the old-fashioned way, and you should get 14. All right, let's multiply these two. Okay, so once again, multiply their absolute values. So that's square root of 6 times square root of 6. And then add the angles. So it's going to be 275 plus 220. All right, so we end up with the new absolute value of the product being 6. The sum of my two angles would be 475. Okay, which is fine, but think if you were going to put that in rectangular form, then thinking of what's the cosine and the sine of 475. So that's why we typically get an angle that's the least positive angle, that's coterminal. So you could write this as 6 CIS. If we subtract 360 from that, oh, whoopsie, I'm so sorry, I can't read my own writing. Hey, well, this should be 220. So this should be 495. There we go. Subtract 360 and we end up with 135. So there's the product in trig form. Could convert to rectangular form. If you converted to rectangular form, it would be negative 3 square roots of 2 plus 3i square roots of 2. Okay, so let's talk about dividing. I'm figuring you can guess what we do. Okay, we divide the r values because we're dividing two complex numbers, and instead of adding the angles, we subtract. So we're going to divide. 12 divided by 3 is 4. And then we're going to subtract. So you just have to be careful the order that you're subtracting. It's the top minus the bottom. So here it's 48 minus 6. So we end up with 4 CIS 42 degrees. Okay. Now, depending upon what form you want that quotient in or that result in, you just go from there. Because this is not a nice unit circle angle, if I'm going to give rectangular form, I have to use a calculator, and I don't want to, so I'm going to leave it in trig form. All right, another one. 5 CIS negative 180 divided by 15 CIS 135. Oops, got a little extra degree symbol in there. Pretend like that's not there. And go ahead and divide. Now, we have to divide. It's top divided by bottom. So it's basically simplifying that, which comes out to be 5 over 15 reduces to 1/3. And then we subtract. Now, if you want to subtract, that's fine. You've got to be careful, though, with the negative. It's negative 180 minus 135. If that doesn't work for you, then go ahead and convert negative 180 to a positive angle. That's coterminal, which is actually positive 180. Okay, so that might actually be a better option. So let's just write that below it. Or you could do 180 minus 135. Okay, and you'll see that we get the same angle. It's just one is going to be negative and one is not. So it's up to you. Here we get, when we subtract here, I get what? Negative, I don't know. I didn't do that. So let me think about that. 180, 315, I believe. Okay. When we subtract here, we get 45. Are those two angles coterminal? Should be. Okay, so it'd be 1/3 CIS. If they ask you for an angle between 0 and 360, you would want to go with the 45. If you came up with the negative 315, then you would convert by adding 360 to get the least positive coterminal angle. All right. Now, before we move on, these are fine. We don't need trig form to multiply and divide complex numbers. Okay, but this is a situation where trig form helps us do something that is tedious in algebra. Okay, so if we convert to trig form, we can do some things in a quicker fashion. So right now, the password is psychedelic. The password is psychedelic. Okay, so let's talk about raising a complex number to a power. Okay, my complex numbers are cosine theta plus I sine theta in the standard form. If I'm going to square it, I'm going to take it times itself. And we just did multiplication, so we know we multiply the r's, we get r squared. We add the angles, and we get theta plus theta, which is 2 theta. Okay, so there's the product if we square a complex number. If we cube our complex number, we're taking it times itself 3 times. So we're saying r times r times r is r cubed. And then I'm taking my angle, which is theta, and each complex number, theta plus theta plus theta is 3 theta. So if you can see a pattern, if I wanted to do, let's say I wanted to do z to the 28th power, my complex number to the 28th power, I would have r to the 28th, and then I would have CIS. I'm adding up 28 angles that are the same, so I'm taking an angle times 28, so that would be 28 theta. So we want to come up with a rule in terms of n, where n can be technically any real number. We'll only see it, I take that back. We will see it as integers and fractions. All right, so there's a theorem for that, de Moivre's theorem. And de Moivre, Abraham de Moivre, here he is, over here on the right. Nice looking wig he's got going there. If you look back in the day, almost all the mathematicians look very much the same because they all have a similar wig. Rene Descartes is the one that has is most distinguishable because his hairdo isn't quite as curly and big. But little fun tidbit about Abraham de Moivre, he is French. So if those of you took French, I'm probably butchering it. Okay, so here's our rule as we thought. What are we going to do? We take our absolute value r and we raise it to whatever our power n is. And then we take our angle and we multiply it by n. Okay, de Moivre's theorem only works on complex numbers in trig form. Okay, all right, so here's my complex number in trig form, 5 CIS 75 degrees. Okay, now I could do this. I could say 5, I'm using CIS because it's faster. And I could take it times itself, right? 5 times. That wasn't very good. All right, so, but I don't want to do that, okay? That's just a lot of multiplying. So we know, or we can go faster now, and we can say, okay, well, we're going to be doing 5 times itself 5 times, so that would be 4 times, I'm sorry. Oh, whoops. Well, that wasn't very smart. 4 times. So not horrible. All right, but you'll see when it wouldn't be fun. Okay, so 5 times itself 4 times. So that would be 5 to the 4th power. We're using that power 4. And that would be CIS. And then we're going to we're adding up 75 4 times. So we're going to take that power 4 times whatever the angle is, times 75. Okay, so we get 5 to the 4th power, which is 625. CIS, 4 times 75 is 300. Okay, and there is the result. What do I get after I raise it to the 4th power? I get a complex number that is 625 units from the origin on an angle of 300 degrees. So if you're a visual person, here's kind of our representation of it. 300's down here. Here's my angle. And my complex number, if I call it Z, is going to be down here. And Z is going to be a distance of 625 from the origin. Okay, if I could convert it to rectangular form if I wanted to. All right, now here's where trig would be nice. Okay, because if we had to stick with algebra, we would have to do this. And we would have to do that 10 times, which is long and tedious. multiply the first two by distributing, then take it times the next one, then take it times the next one. So here's where trig form is fabulous because it's such a big power. Okay, so first thing to do is write it in trig form because as you could just see, it's pretty nice to raise a complex number to a power in trig form very fast. And then we could go back to rectangular form. Okay, so just a quick look, if I graph it, like is always a good idea, it's -1 plus 1. Okay, here's my complex number here. Remember, I need the distance that it is from the origin, and I need its direction angle. All right, now keep in mind our special situation here. We know that A is -1 and B is 1. B is the number in front of I. Notice how those are the same. They're both 1, even though one is negative. One of them is negative. So this is -1 and this is +1. So I have an isosceles right triangle, which tells me it is a 45, 45, 90 triangle there. All right, so that means I know the reference angle for theta, and we can find R the old-fashioned way. So we can say R is -1 squared plus 1 squared. So R is the square root of 2. R is always positive because it's a distance. And I know theta is the angle in quadrant 2 that has a reference angle of 45. So it's 180 minus 45. Which is 135. And now we've got it in trig, or we can write it in trig form. Okay, so it's going to be square root of 2 CIS 135. Okay, now write it in trig form. That's your first step, and then do the power. Raise it to the power. So if I wanted to raise this to the 10th power, I now want to raise this to the 10th power. So I'm going to take then square root of 2 and raise it to the 10th power. And then I'm going to take my angle 135 and multiply it by 10. To get my result. So square root of 2 to the 10th power is basically 2 to the 5th, which is 32. CIS. And so this becomes how much? 1350. Okay. Now let's think about that for a second. If I said I want you to go back to rectangular form, right? Because we did this because we wanted to know what is this equal to, what's that complex number in rectangular form. Now, this is where it's up to you, it's preference, but the reason that we say to write this as an angle between 0 and 360 is you can quickly come up with the sine and the cosine if it is a nice unit circle angle. So take off all the full rotations. Least positive coterminal angle here would be 270. All right, so there it is in trig form. Now I can go back to rectangular form. So it's going to be 32 times the cosine of 270, which is 0, plus the sine of 270, which is -1i. Whoops. All right, so this comes out to be -32i. So if I did this to the 10th power, I would get -32i as the trig form, or sorry, the rectangular form. So if you want to check it for fun, you can do the algebra and let me know how that works out.